Okay, assalamualaikum guys. So this is the continuation of the question 3 that we did earlier. Remember I mentioned about part B, calculate the reaction force at point A and point G in figure 5. So this is actually figure 5. Sorry for the initial confusion. And we have part C, which is determine the force in each member of the Pratt truss in figure 5. State if the members are in tension or in compression. Okay. So first and foremost, let's go to B first. B is actually pretty straightforward because they're only asking for the reaction force in point A and point G. So A, as we know, is a pin support force, so we know it's supposed to have the AX and AY reaction forces, and G is a roller, so you only have FG. So my only suggestion is you take the moment at point A. Okay, if you take the moment at point A, and then you can actually try to find what is the force at G, and easily you can find AY and AX. And here's a bonus tip: AX will be 0 kilonewton. Because why? Because the thing is, we know that summation of fx, okay, equals to 0, and the direction where it's going right is positive, so therefore ax is clearly 0 kilonewton. Okay, done. Easy. Now you take the moment at point A. Okay, you take the moment at point A to be 0. Okay, counterclockwise. So you have negative 10 kilonewton times 4 because it's going clockwise, and minus 20 kilonewton going with 6, minus 10 kilonewton going in 8, plus FG 1 2 3 4 5 6 12, sorry, not 11, 12, that equals to 0. Okay, so if you simplify the equation, so negative 10 times 4 minus 20 times 6 minus 10 times 8 minus 240 plus 12 FG. So therefore 12 FG is equivalent to 240, and therefore FG is equivalent to 240 divided by 2 is supposed to 240 divided by 12, sorry, would be 20 kilonewton, and the direction is upwards. Okay, so that's your FG. Now we know that summation of Fy is equivalent to 0. Okay, remember that we're taking the upwards as positive, so we know that Ay minus 10 minus 20 minus 10 plus 20 is equivalent to 0. So this cancels out, so we have Ay minus 20 is equivalent to 0. So therefore Ay is equivalent to 20 kilonewtons. So there you go guys, very easy. Free 5 marks. Okay, so this should be a very easy 5-mark question you can easily get for free. All right, now we come to the next question, which is very tricky actually. Determine the force of each member of the Pratt truss and state if the members are in tension or compression. Now before we go to this, I will show you the problem, because actually I've done this problem some time back, and I think I've also given this as a bonus problem to you guys during our first meeting in class. If any of you have done the bonus problem, then maybe you have an idea of how the Pratt truss looks like or how to solve this kind of problem. But if not, it's okay. I'll walk you down to the solutions. Okay, so the first and foremost thing actually is to identify the zero force members, because here I managed to identify 4 zero force members: BL, CL, HE, and HF. And you might be wondering how I did it. Okay, let's look first at BL. Okay, so you can see that at BL, at joint B, there is no support reaction, right? There is no support reaction whatsoever. So if there's no support reaction, therefore BL must be a zero force member, because at the end of the day, you see that there's two collinears, AB and BC, and BL. But there's no support reaction at point B, and even at L also there's no support reaction. So therefore, you can easily take out BL. Okay, that's a zero force member right here. Another thing very interesting about the Pratt truss is that the Pratt truss itself is actually symmetrical. Okay, maybe should I have used change the line a bit, sorry, yeah. I'm going to use a dotted line actually, it'll be much more nicer to look at. Okay, so it's symmetrical. So whatever, so if this is a zero force member, oops, this is a zero force member, that means that, sorry, that means that FH also is a zero force member. Okay, so FH is also a zero force member. So you already have two zero force members. So now we look at join L. Okay, now join L, we have only AL, AK, and CL. Okay, because BL already is gone and then HS already gone. Now we can see at this that CL is also a zero force member because AL and LK is collinear, but CL is perpendicular and there's no support reaction L, therefore CL is also a zero force member. So you can get rid of CL also. Okay, and same thing also goes for EH as well, because at the end of the day you look at H, there is no support reaction and EH is perpendicular to IH and GH, but there's no support reaction H, so EH is also zero force member. So you already end up having four of them zero force members. Okay, so then I redraw the truss structure where the zero force members don't exist anymore. And of course covered the measurements and also the support reaction forces. And I already determined the support reaction forces earlier. I already determined it earlier. So with that being said, so we have to analyze each and every truss. So we start with you can start with point A or point G first, okay? Because I started with point A for my case. So at pin A, we already have the support reaction force AY. Then I assume that the member AL is obviously under tension, so that's why the direction is the direction is going that way. The same also for AB as well. So after using the equilibrium equations of Fx and Fy equals to 0, I managed to get the direction for AL and AB. So AB is clearly under tension, follows the correct direction, but AL is the opposite direction, so therefore it's in compression. Then moving on, I went with pin L first. Okay, I started going to pin L actually. And as you go to pin L also, it's a bit easier because pin L only has one direction, by the way, right? Since they are both 0. So therefore, we can say that LK is also under compression as well. At pin B, okay, since it's only just two forces, AB and BC, so we know that BC is also under tension as well. At pin C, because pin C is surrounded by 1, 2, 3, and then three members, and they have 110 kilonewton force acting downwards. So pin C clearly would be under tension anyway, because you have a 10 kilonewton force acting downwards. But nonetheless, I did calculate it, so you know that CK is clearly under tension, and CD also will be under tension as well, right? Because BC, yep, so it's following the correct sign conventions. And then also I proceed with pin K as well. So pin K, I think there's a lot of truss members there. I think it's like how many? 1, 2, 3, 4. You already know CK, you already know LK. Now you do not know for DK and DK and DJ, right? KJ. So you of course need to solve, right? You need to solve in order to determine what is the forces there. Okay, so I assume initially all of them are in tension. And how I get the direction, you ask me how I get these small directional angles. Because already mentioned that for this side, it's only 2 meters. And this is 2 meters, so that's why the direction is 2 to 2 or 1 to 1 also. Okay, and the same also for KD, because this is about, I think, 4 meters. This is about 2 meters, so this one is a 2 to 1. Okay, so using the directional triangles are quite helpful actually, because they allow me to find the forces across the members. Okay, and after that, after solving for KD and KJ, and the same also I go for point J as well. Point J, there's also 3 trusses, I believe. 3 trusses. Okay, so you already have KJ, then usually you can find the other 2 pretty easily, to be honest. Okay, then from there you can go to pin D, I think, which I'm not mistaken is point J. Pin D. So pin D, actually you have some other members as well. Alright, because pin D usually is connected to 1, 2, 3, 4, 5, and you have a 20 kilonewton force also acting on this direction. So you already know a couple of forces, and some of them you don't, which I believe is DI and DE itself. When DI is under compression, DE is under tension in this case, after you follow the sign convention, okay? And the triangle also, I think I already explained to you, because the triangle we get from looking at here. So say this is 4 meters, right? This is 2, so this is obviously a 1 to 2 triangle, okay, and so on. So I didn't really use cosine and sine so much. I mostly utilized the triangle, actually, the triangle rule, because it actually makes things a bit more easier. But and compared to finding cosine and sine, because cosine and sine is always a headache to find the angle, so that's why it's best to use the triangle rule anyway. Okay, after pin D you have pin E also, okay, where you'll find EI and EF, where EI is under tension, EF is under tension as well. Pin F also, you find that FG is under tension, remember FG is under tension as well, right? We're gonna analyze it, pin E, then pin F, right? You find all the trusses. Then automatically you can find for point G, and you can find for H and I also. Members H and I. So at pin G, you see I analyze the forces. I found that GH is under compression. Then you can easily find the members HI itself. So IH is under compression. So that's it for the Pratt trusses actually. And this problem, I'll admit, is quite lengthy. It's a lot of things to solve, because you have to solve for this, you have to also solve for this, and this as well, right? You have to actually solve for all the other forces, okay? And it's, I would say, a bit complicated. So if you got a problem like this in the exam, my honest advice, honestly, is just to solve part of it, okay, and probably skip for the other questions, the easier questions in the final exam tomorrow, okay? And then later, if you have time, you can come back and finish solving the whole Pratt Trust. If not, it's okay, as long as you at least maybe say solve partial of it, then it should be okay actually. As long as you solve the, as long as you solve it partially, also it should be okay as well. You also get some marks. It's quite large, 15 marks. So maybe if you get, let's say, 7.5 marks here and 5 marks there, 12.5 marks, that's also pretty good as well, okay? So yeah, that's about it. I will also share the final exam questions that I've been working on, so you guys also can actually see the hard copy, if let's say you guys don't have the time to watch the full video. And yeah, I wish you guys all the best for tomorrow's exam. May Allah make it easy for you. Assalamu alaikum wa rahmatullahi wa barakatuhu.